Hi, this is Mr. Von Neumann. In this final part 3 of our tutorial for the exoplanet, we figured out where the exoplanet needs to be livable like Earth, and we came to the conclusion that for GJ 9689b, it's got to be at 0.40 AUs to have a temperature very similar to Earth. So in this final part, we're going to take where you want it to be compared to where it actually is and figure out if it's too close, too far. I described that in the instructions here. So where it is in relation to where you want it to be. And I give you a formula of want to be divided by actually is that I just kind of made up there, but it works. So first, let's think about it. And I'll actually draw it out here for you. So it is supposed to be, we want it to be right here at 0.4. That's where we want it. But it actually is, let's see where it actually is. Where it actually is, and I tell you that in here, the semi-major axis is the actual distance, the AU, the planet is away from the star. So the semi-major axis is 0.11. So we wanted it over here, but it's actually right about here. So it's at 0.11 AUs. So the first thing you have to kind of think about is it too close or is it too far? So if we wanted it there at 0.4 and it's at 0.1, then it is clearly too close. It being too close is going to mean that it's either going to be too hot or too cold. And if you think about that, if you're too close to the heat source, it's going to be too hot. So it's too close, it's going to make it too hot. And hopefully you can look at this right now and figure out that if it was supposed to be at 0.4 and it's at 0.1, that would be 4 times too close, about. So in our analysis, we'd say that, so we needed GJ to be at 0.4 AUs, and it's actually at 0.11 AUs, which is, and we know it's about 4 times too close, but I'm going to show you how to run the formula right now to see exactly how many times too close. So our formula would be want to be, like where we want it to be, divided by where it actually is. So we wanted it to be at 0.4 AUs. It actually is at 0.11 AUs. When you divide that correctly on a calculator, you're going to get 3.6. Like I said, we estimated it to be 4. It's actually 3.6. So we would say, which is 3.6 times too close to the sun, to its star. Now, the next step, we know it's 3.6 times too close now, which means it's too hot. So it will be too hot. 3.6 times too close to its star, and it will be too hot. With a temperature, and here comes the part where we have to figure out the temperature. So we could basically say that a hot temperature on Earth, so we'd say that hot temperature on Earth would be, an average mildly hot day, 70 degrees, and the absolute hottest temperature it's been on Earth as of 2021 was 134 degrees Fahrenheit in Death Valley. So multiply each of those by 3.6 to get your temperatures, estimated temperatures on this planet. So after multiplying each of these by 3.6, since we're 3.6 times too hot, we get a temperature of 254 all the way up to 482 degrees. If you Google melting points of metals, you'll see aluminum melts at 1200 degrees Fahrenheit. So even though that's really hot, we could land a spaceship on there, most likely. 254, not very pleasant. Probably not one that we could live on, but we could walk on it.